Hello everyone, and welcome back to the channel. So in this episode of sensors, brick rig sensors, that is, we are looking at the acceleration and normal acceleration sensors. Now, if you've seen the last video, this will look quite familiar because it's very much similar to how the speed sensors work. So with acceleration sensors, normal ones, not the normal acceleration one, but just your baseline acceleration sensor, it detects change in speed. So basically, let's say you're going 10 meters a second, and then in the span of 1 second, you go from 10 to 20 meters a second. That would register as 10 meters per second squared for an acceleration sensor. And it will detect this change in speed in any direction. So the graph for that looks something like this, where at your minimum value, below that, you're outputting 0 signal. And this is in meters per second squared, which is our standard unit of acceleration. Maximum, beyond that, it's just infinite positive for your signal strength, and between that it scales linearly, as you can see. Now for the normal acceleration sensor, you can see we've got a positive and a negative here, and what that means is basically it will only detect acceleration and deceleration in the direction of the sensor's sensing. Or yeah. Anyway, it'll only detect it in that direction, which means you can have negative values. So let's say you sped up, right? And so that gives you 10 meters a second squared of acceleration, right? And then you, let's say in the next second, you drop down to 0 because you just hit a wall. So that would be then negative 20 meters a second squared, like that. So, and that would just be an absolute ones, that regardless of your inputs, and then your inputs can actually change when the sensor does something about this kind of change in speed. So in that example I just gave, you accelerate 1 second, right? And that puts you up here in terms of input. So that's positive input. And then you decelerate even more, and that puts you over here, which is your negative input. I don't know if that makes sense. And then of course here, 0 is between your max and min value, and you're not accelerating at all. You're stationary. Or you're not changing your velocity. So, uses of such sensors are as follows as far as I can tell. I'm sure there's other ones, but these are just the ones I thought of. Fake RPM gauges, launch control for vehicles. So for instance, some modern cars have launch control, which basically means you floor it and then it just automatically chooses how to accelerate. I'm not sure if that's a practical thing in brick rigs yet, but you could certainly try. And then dynamic cruise control, which I'll get to in a second, and wing rip loading for realism or for pain. So let's start with the wing rip one, since that's interesting. You would want to be using a acceleration sensor, right? And you can see here the forces. So you just pulled out of a dive, high vertical change of velocity. And basically any acceleration that would be over 90 meters a second squared would then cause detonators you would put in your wings or something else to go off, and your plane would disintegrate. And so for this example, let's say we want a 9G maneuver, which is quite ambitious for a prop plane as displayed here, but probably more in line with like a modern jet and its wing loading, although it can certainly exceed such things. But anyway, just as an example, So because our force of gravity is about 10 meters a second, I'm estimating, you can basically just use 90 meters a second change, and then your minimum would be 89. So basically past 89, it, you know, so here would be 89 and there would be 90. So once you pass into that range, anything in here is going to detonate a detonator on your plane, which would limit you to 9G maneuvers. That's something you can do. If you also wanted to make like some sort of pilot blackout system, that could also be useful for such things. Now, as for cruise control, you would probably want to be using a normal acceleration sensor, although an acceleration sensor would also work, just probably not as well, because it detects in every direction rather than just that. So it would also be detecting your climb rate rather than just your forward acceleration. So you'd basically want to set your min and your max basically right around 0, just above and below, so that it sort of, I wrote this down here, high frequency thrust pulses average out to speed at time of activation. So this, the reason it would be a variable speed is because you basically use your normal boosters to get up to your cruising speed. You turn off your normal boosters and then you turn on your cruise control boosters. And then if you decelerate, you can see there, that's our min, decelerating 1 meter per second. So, if you accelerate up to 1 meters per second, it will turn off thrusters. If you decelerate, it'll turn on the thrusters. So it'll sort of pulse, but you'll keep a steady speed. So anyway, this has just been the acceleration sensors, and they're not super complicated. They're just a little bit harder than your normal speed sensor and a bit less applicable. There's not exactly a ton you can do with them that's overly useful. I'd say the most useful of all these things is definitely the dynamic cruise control. Outside of that, it's like not that great. So it's great, but not for brick rigs. I'm sure it's useful for other things that I just haven't thought of. But yeah, I'm gonna cap it off here, and stay tuned for the next video. We'll be covering angular speed sensors. Bye.